welcome to this next video. In this video, this is video number 3 in our series or playlist on integration. So what we're going to be learning in this video is substitution rule or some form of a reverse chain rule. Just a few reminders. Remember that in further studies, you are given the formula on how to calculate the integral, on how to determine the integral. And just a reminder of the chain rule. So if you've got a composite function, you'll see that there are two functions put together to create a new function. That's what a composite function is. You'll see that if you had that and you needed to differentiate it, you'd use the chain rule. And you'd use the chain rule by differentiating the function inside the composite function, and then you differentiate the outer function. This is going to be a little bit more essential, especially when we get to do the substitution rule. Essentially, when do we use a substitution rule? We use a substitution rule in most situations where we've got composite functions, where also the expressions of the functions that we're given, we cannot get them into a form which is easily and nice to integrate. So therefore, we apply a form of a U substitution. You will see that in a U substitution, you will have a composite function of some sort, and you will be able to find a derivative of that composite function, or a form that looks close to the differentiable part. And therefore, that will allow us to then use the integral of U, and then also now integrating with respect to du. And the most important thing is that because we are going to let the substitution in our case be U, I'm sure you can use all sorts of letters, but it is highly encouraged, or a lot of textbooks use U as a substitution. Once you use U substitution, then your function will become a lot more easier to integrate and will look a whole lot more familiar. So let's just dive deep into this, and I've got two questions that I'd like to tackle in this video. So let's begin with the first one. So here you're looking at a complicated expression. This is to the power 4, but what you do realize in doing this is that a form of substitution would be able to help in getting to do this, and this R is indeed a composite function. But let's look at this. If you look at this function over here, it is raised to the power 4. And if you look at it, the derivative of this part over here is 3x squared. So therefore, this is in somewhat the derivative of this particular expression. And therefore, you've got that 4, and therefore, there is a relationship that looks some form of a derivative. So what we then do to make our jobs a little bit easier, we introduce a substitution. And mainly we'll call this a U substitution, because that's what a lot of literature that you get there find. So let us go back to this. So what you'll do, you will let U equals to this expression, which is raised to the power 4 in the big polynomial. So this becomes x to the 3 plus 4x minus 5. And then we'll take the derivative of U with respect to x. So this becomes du over dx. And you will see that the derivative of this gives us 3x squared plus 4. But hey, aren't you looking at something that looks a little bit familiar? You can see that this 3x squared corresponds to 3x squared plus 4 there. So therefore, what we will do, we'll just rewrite this and become du equals to 3x squared plus 4. And then we'll just cross multiply the dx there and put it as dx. So therefore, we are only left with du. So what I will then do, I will rewrite the entire integral now. All right, so the entire integral we get there, I will rewrite it such that it looks like the function that we have. So I'll rewrite this as x to the 3 plus 4x minus 5 to the power of 4. And what I'll do, I'll just rewrite this expression 3x squared plus 4 here and put dx. And I want you to be able to notice something here. So what I want you to be able to notice is that you'll see that this expression inside here, if we're using the substitution we made there, that's going to be du. That's going to be u. And this expression over here, that you worked out, you'll see that that gives you what the entire du is. So by this substitution, we can now rewrite our integral nicely, looking as the integral of u to the 4 du. So using this substitution, it makes our life so much easier. So now we can get to a point whereby we can find this integral now quite easy. So according to our integral, so the integral of this will become u to the 5 over 5 plus the constant for integration. And can you see that this u substitution has made this problem so much easier? And the most important thing now is to sub back what u was, because ultimately you have to write your solution and the answer that it was. So you get x to the 3 plus 4x minus 5. Now this is to the power of 5 over 5 plus c. So therefore, this gives you the integral of that very complex looking expression. So in this, I want you to note that the du, or letting the substitution u, makes it easier for us to get this entire integral into the standard form that we are very much used to in our first two videos that we've covered. And therefore, this u substitution makes integrating complex composite expression to make them so much easier. So I hope this makes a lot of sense. Let us deal with the next question over here. So here as well, you can see you've got a composite function. What I will do is just rewrite this integral into a form. So take that to the power of half dx. And we can see that there is some form of a relationship between the x squared there and the 2x. And it does look like some form of a derivative. So what we'll do, we will let u equals to the expression that is raised to the power of a half. And therefore, the u becomes 1 plus 2x. This becomes x squared. We take the derivative of this, which is du with respect to x. So this gives us 2x. And therefore, we can rewrite this as du equals to 2x dx. And you can clearly see from this expression again, I want to remind you, this part will be du. This part inside the rational part becomes u, and therefore we can rewrite the expression. So what I will do, I'll just make this look, rearrange the entire expression. So this becomes 1 plus x squared to the half, and then put 2x dx. And from here, I want you to be able to pick up that this part here is u, and this part there is du. And therefore, we can easily work out what our integral is. So now in this case, we use u substitution. This becomes u to the half. This becomes du. This is now in the form of an integral that is easy for us to do. So we know that with the integral, we'll add a 1 there, giving us 3 over 2 over 3 over 2 plus the constant of integration c. And then what we'll do, we'll substitute this and also sub back what u was. If you recall at the top, our u was 1 plus x squared. So this becomes 2. Our u is 1 plus x squared. This is all going to be to the 3 over 2, everything over 3 plus c. And that is the u substitution. Watch out for the next video where we'll be doing more examples that involve u substitution. I hope this has made it easier for you to understand how to do u substitution.